Imagine standing beside a machine taller than a 20-story building, watching it lift a steel container weighing more than 30 tons as if it were a child's toy. Every single day, thousands of these containers arrive and leave the world's largest shipping terminals without stopping for a second. Most people never think about the hidden world behind the products they buy online. But here's what nobody tells you. One tiny delay at a mega terminal can ripple across the entire global economy. Today, we're going behind the gates of these incredible ports to discover how they keep the world moving. Think about this. Nearly everything around you, from your smartphone to your refrigerator, likely passed through a shipping terminal before reaching your home. These ports operate 24 hours a day, 7 days a week, handling millions of containers every year with astonishing precision. The air echoes with engines, horns, and the deep rumble of giant cranes moving non-stop. And this is where our journey into one of humanity's greatest engineering achievements truly begins. A shipping terminal may look like a forest of steel, but every beam has a remarkable story. Much of the structural steel begins as iron ore mined in Australia's Pilbara region and Brazil's Carajás mine, two of the richest iron ore sources on Earth. The ore often contains more than 60% iron before being processed into high-strength construction steel. Imagine rocks blasted from ancient mountains eventually becoming cranes that shape global trade. The iron ore travels hundreds or even thousands of kilometers by freight train before reaching giant blast furnaces. Inside these furnaces, temperatures climb above 1,500 degrees Celsius, turning raw materials into molten iron. Carefully measured amounts of limestone remove unwanted impurities, while metallurgical coal provides the intense heat needed for the reaction. The result becomes the backbone of the world's biggest cranes and terminal structures. Iron ore travels hundreds or even thousands of kilometers by freight train before reaching giant blast furnaces. Inside these furnaces, temperatures climb above 1,500 degrees Celsius, turning raw materials into molten iron. Carefully measured amounts of limestone remove unwanted impurities, while metallurgical coal provides the intense heat needed for the reaction. The result becomes the backbone of the world's biggest cranes and terminal structures. But steel alone cannot build a modern shipping terminal. Copper arrives from Chile and Peru to create kilometers of electrical wiring. High-grade aluminum from Australia and Canada helps reduce weight in specialized equipment, while advanced electronics rely on silicon refined from ultra-pure quartz. Every component begins its own journey long before the first container ever reaches the dock. Now imagine moving these enormous materials across oceans before the terminal itself even exists. Bulk carrier ships transport iron ore weighing more than 200,000 tons in a single voyage. Heavy lift vessels deliver crane sections so massive they cannot travel by ordinary roads. Every shipment demands careful planning because one missing component can delay an entire construction project worth billions of dollars. Building these terminals also comes with environmental challenges. Engineers now recycle millions of tons of steel, use electric equipment where possible, and install shore power systems that allow ships to shut down their engines while docked. These innovations reduce emissions and improve air quality around busy ports. But the real magic begins after the steel rises into the sky, because that's when these giant machines come alive. And what happens next surprised even experienced engineers. Now the real transformation begins. Before a single crane can lift its first container, thousands of tons of steel plates arrive at specialized fabrication plants. Giant CNC plasma cutters slice plates up to 150 millimeters thick with incredible precision, while computer-controlled rollers bend massive sections into the curved shapes needed for crane booms. Every cut must stay within a tolerance of less than 2 millimeters because even a tiny error can become a major problem once the crane stands more than 100 meters tall. Next comes welding, one of the most demanding stages of the entire build. Robotic welding systems fuse steel using electric arcs hotter than 6,000 degrees Celsius (10,832 degrees Fahrenheit), while automated positioners slowly rotate enormous sections weighing hundreds of tons. Each weld travels at carefully controlled speeds of around 30 to 60 centimeters per minute, creating joints strong enough to survive decades of constant lifting. The air fills with the smell of hot metal, while showers of sparks light up the factory like fireworks. Once the steel structure takes shape, engineers prepare every surface for protection against harsh ocean conditions. Massive blasting chambers fire steel grit at high speed to strip away rust and contaminants before multiple protective coatings are applied. The painted components then cure under carefully controlled temperatures of about 20 to 30 degrees Celsius, 68 to 86 degrees Fahrenheit, for several hours, creating a durable barrier against saltwater corrosion. Without this process, the sea would slowly eat away at the steel year after year. Now comes the assembly stage, where pieces built in different factories finally come together. Heavy-duty crawler cranes capable of lifting more than 2,000 tons carefully position each section while laser alignment tools verify every connection. Hydraulic torque tools tighten massive bolts with forces reaching thousands of Newton meters, ensuring the entire structure behaves like one solid machine. Every movement happens slowly because a single mistake could damage equipment worth millions of dollars. With the structure complete, technicians install the heart of the crane. Powerful electric motors drive steel wire ropes around massive pulleys, while precision gearboxes transfer enormous amounts of torque with remarkable efficiency. Advanced control systems coordinate every movement so containers travel smoothly through the air without dangerous swinging. What looks effortless from the outside actually depends on thousands of perfectly synchronized mechanical parts. Finally, the finished crane arrives at the shipping terminal for commissioning. Engineers run hundreds of test lifts using containers loaded with carefully measured weights, checking acceleration, braking, and emergency systems under real operating conditions. The deep hum of electric motors, the sharp beeps of safety alarms, and the slow movement of thousands of tons of steel create an unforgettable scene. But before this engineering giant can enter full-time service, it must survive one final challenge that determines whether it truly earns its place at one of the world's busiest ports. This is where these giants become truly intelligent. Every modern mega shipping terminal relies on thousands of sensors, high-speed fiber optic networks, GPS positioning, and AI-powered software that tracks every container in real time. Imagine watching hundreds of trucks, automated guided vehicles, and cranes move at once without crashing into each other. Most people only see containers moving, but behind every movement, millions of calculations happen every second. As containers arrive, laser scanners measure their exact dimensions while high-resolution cameras inspect every corner for dents, cracks, damaged doors, or missing identification numbers. Optical character recognition instantly reads container codes from several meters away, reducing human error and speeding up operations. AI vision systems flag suspicious damage in seconds, allowing workers to inspect only the containers that truly need attention. What once took minutes now happens almost instantly. As containers arrive, laser scanners measure their exact dimensions while high-resolution cameras inspect every corner for dents, cracks, damaged doors, or missing identification numbers. Optical character recognition instantly reads container codes from several meters away, reducing human error and speeding up operations. AI vision systems flag suspicious damage in seconds, allowing workers to inspect only the containers that truly need attention. What once took minutes now happens almost instantly. The cranes themselves undergo constant health checks. Vibration sensors monitor bearings, strain gauges measure structural stress, and temperature sensors watch over electric motors before problems become visible. If even the smallest abnormal vibration appears, maintenance teams receive an alert long before a breakdown can stop operations. Predictive maintenance has dramatically reduced unexpected equipment failures at the world's busiest ports. Quality standards leave almost no room for mistakes. Critical crane components undergo ultrasonic testing, magnetic particle inspection, and precision laser measurements that verify tolerances down to fractions of a millimeter. International standards such as ISO and safety regulations require extensive documentation before equipment enters service. Even a small defect can lead to a component being repaired or replaced before the crane lifts its first commercial container. But here's something surprising. Even with all this advanced technology, experienced operators still play a critical role during unusual situations. Strong crosswinds, oversized cargo, or emergency operations often demand human judgment that no computer can fully replace. Years of experience allow skilled operators to sense subtle movements that even sophisticated software may interpret differently. Sometimes the human touch still outperforms the world's smartest machines. By the time a container leaves the terminal, it has passed through dozens of automated checks, multiple safety systems, and countless human decisions working together in perfect harmony. Every successful lift represents precision engineering, advanced software, and skilled professionals operating as one seamless team. Yet the story doesn't end at the dock, because these incredible terminals shape the entire global economy in ways that few people ever imagine. And the numbers behind that story are almost impossible to believe. Now step back and look at the bigger picture. Around the world, container ports handle more than 800 million TEUs of cargo every year, connecting factories, farms, and cities across every inhabited continent. Global container shipping supports trade worth trillions of US dollars annually, making modern shipping terminals one of the most important pieces of infrastructure on Earth. If these terminals stopped operating for just a few days, supermarket shelves, factories, and online retailers would begin feeling the effects almost immediately. Today, China leads the world in container throughput, followed by Singapore, South Korea, the Netherlands, and the United States, with many of the busiest ports located in Asia. Over the past 50 years, shipping terminals have evolved from mostly manual operations into highly automated logistics hubs powered by robotics and artificial intelligence. The world's largest container vessels can now carry more than 24,000 TEUs on a single voyage. Think about this. That's like transporting an entire small town's worth of household goods across an ocean in one trip. Did you know that a single modern ship-to-shore crane can cost over 10 million US dollars? Or that some of these machines stand more than 140 meters tall, higher than many skyscrapers? And here's another surprising fact. Many mega terminals continue operating through the night using thousands of LED lights that make the port look like a futuristic city glowing beside the sea. Every hour, hundreds of containers quietly begin new journeys to destinations around the world. The future promises even greater change. Engineers are developing fully electric cargo equipment, hydrogen-powered terminal vehicles, AI systems that predict congestion before it happens, and digital twins that simulate every movement across an entire port. Over the next decade, smarter automation and cleaner energy could make shipping terminals faster, safer, and more environmentally friendly than ever before. The hidden world behind global trade continues to evolve every single day. From ancient iron ore buried deep beneath the earth to towering cranes that move global commerce with breathtaking precision, you've now seen the incredible journey behind a mega shipping terminal. Every container, every crane, and every carefully planned movement represents decades of engineering, innovation, and human determination working together. The next time you see a cargo ship on the horizon, you'll know you're looking at one small part of a system that quietly powers everyday life across the planet. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to